Alright, let's look at part C. So part C says a different population is modeled by a function y that satisfies a separable differential equation dy over dt is equal to y over 5 times the quantity of 1 minus t over 12. Find y of t if y of 0 is equal to 3. This is an A-B concept, so it should be review, but we'll still do it anyways, just to verify. So step 1 is write down the question. And we have to remember that the most important step is to separate the variables. This is the most important step. Because if you don't separate the variables, you get no points on this part of the FRQ. And usually, when it comes to finding the particular solution based off a differential equation, those usually give about 5 or even 6 points. So they're very crucial. So, separate the variables so we could divide y on both sides, and we can multiply dt on both sides so that we get dy over y is equal to 1/5 of 1 minus t over 12 dt. I'm just gonna distribute this real quick so we get 1/5 minus t over 60 dt. Now that we've separated the variables, we could integrate both sides, but when we integrate, we get the natural log of the absolute value of y is equal to t over 5 minus t squared over 120 plus c. Don't forget the plus c. That's also important. Alright, so now that we have the plus c, we could exponentiate both sides so that this becomes just the absolute value of y is equal to e to the power of t over 5 minus t squared over 120 plus c. I'm going to rewrite this side so that we get e to the power of t over 5 minus t squared over 120 times e to the power of c. This is exponent rules. Now I'm going to get rid of the absolute value so that we get y is equal to the plus or minus. I'm going to put the e of c in front this time. E of c times e raised to the t over 5 minus t squared over 120. Now usually we just simplify this. We could call it a different variable, so we could just call this like k. So k is equal to the plus or minus of e to the power of c. So basically we get y is equal to k times e to the power of t over 5 minus t squared, a little crammed up there, over 120. From there we could plug in our initial condition, which is y of 0 is equal to 3. So we'll do it over here. 3 is equal to k times e to the 0 power, essentially. If you plug in 0 into both of these, you get 0. So basically you get 3 equals k. It's pretty easy enough. So now all I have to do is write the final particular solution. So we get y is equal to 3e raised to the power of t over 5 minus t squared over 120. And that is it. And I'm just going to review. Once again, I'm just going to stress the importance of how crucial this part of the question is. Here's the scoring guideline. And right here, note 0 out of 5 points if no separation of variables. We get 1 point for separating the variables. You get 1 point, you get another point for the antiderivatives. You get another point for the constant of integration, which is the plus c. You get another point for using the initial condition, which we did right here. And you get the last point just for solving for y. So, yeah, it's a large chunk of points up for grabs in just one part. Hopefully, if you know how to do this, it should be an easy 5 points. Now, lastly, we're going to go over part D, which says that for the function y found in part C, what is the limit of y of t as t approaches infinity? So all we have to do, this is basically a limit problem. We need to find the limit of y of t as t approaches infinity. Y of t is basically what we found in part C. So this is equal to the limit of 3e to the raised to t over 5 minus t squared over 120 as t approaches infinity. Now, I'm going to attack this in a more conceptual way. So I'm just going to look at the top of the e, the power. So basically we have t over 5 minus t squared over 120. That's what we have here. So, as you could see, this t is 1 degree higher than this t, meaning it's going to, when you plug in larger numbers, this side is going to grow faster than this side. So essentially, we're going to have a small number minus a big number, and if we go all the way up to infinity, this is going to pretty much equal negative infinity, right? Because this is increasing at a faster rate than this side. So this part will become negative infinity. So essentially we are left with 3e to the negative infinity, which can be rewritten as 3 over e to the infinity power, which just becomes, 3 over a fairly large number, and 3 over a fairly large number is just equal to 0. You see that? So basically we have the limit of y of t as t approaches infinity is equal to 0. And there we go. See on the grading rubric, that's basically just 1 point for getting the answer. And that concludes this FRQ. I hope you learned something. Hopefully it was pretty clear when I gave my explanations on each part. And I'll see you guys later.